In this class, we are going to discuss about power in three-phase systems. Now, as we know, the power in individual phase is given by the product of current and voltage. The power in phase R is the product of VR into my VR into my VR into my IR, and power in phase Y Vy into my Iy, whereas power in phase B Vb into my Ib. This is the power in phase R, this is the power in phase Y, this is the power in phase B. Though this is an instantaneous value of current and voltage, and hence power will be instantaneous. Now, putting the value of VR and Vy, VB, Vy and IR, Iy and Ib. We know the voltage in phase R is Vm sin omega t, the current in phase R is Im sin omega t plus minus theta, depending upon the power factor leading or lagging. Similarly, in phase Y, the voltage is Vm sin omega t minus 120 degree, because Y phase is having phase displacement of 120 as compared to R phase. Similarly, for the third phase, the phase displacement either it is minus 240 or it is plus 120 20 degree for voltage. Similarly, for current, it is plus 20 degree, 120 degree, or minus 240 degree, and angle again is taken as plus minus theta. Now, simplifying this trigonometrical function and taking Vm Im by 2 as common, then the resultant factor will be this, and further simplifying this trigonometrical function, the simplified version will be this one. Now, since we know power consumed is calculated as average over the complete cycle, and for this complete cycle, the limit is 0 to 2 pi. Here we are considering the limit is 0 to 2 pi as a duration of 1 by 2 pi, and then finding out the average of this value, that will be given as Vm Im by 2 cos theta into 3, or it can be written as V, since we know Vm by root 2 is Vrms, Im by root 2 is Irms, or simply it can be written as 3Vi cos theta. Here Vi cos theta is the power in one phase, or if power in one phase is Vi cos theta, then power in three phase will be 3Vi cos theta. Power in one phase. Now, here V and I are nothing but the RMS value of current and voltage, and cos of theta is the power factor. In three-phase system, the power is 3 times the per phase power in a balanced system. The three-phase system power remains constant as instant in the cycle. In this case, since in case of AC supply in single-phase system, the power was having some magnitude like that, or it was having a magnitude like that. But in this case, three-phase system, if there are three phases and having a phase displacement, but power will remain constant throughout the period, and hence in a three-phase system, power is constant at every time of instant. Now, since in three-phase system there are two type of connection, one is star connection, another it is delta connection. In case of star connection, we know there are three resistances are connected at one point, that is known as star point or neutral. Whereas in case of delta, all the three phases are connected in such a way that they makes a loop, and this loop is just look like a delta symbol, and hence name as delta connection. Now, in case of star connection, IL is equal to IP, because whatever current is flowing in this, that same current is flowing in this phase. VL is equal to root 3 times of VP, since in this phase is VP, for this phase is VP, the resultant of these two is VL, and which is given by root 3 times of VL. In case of delta connection, this is VL and this is the VP, because these two voltages are parallel to each other, and hence VL is equal to VP. But if we are considering the current in this phase, this will be the phasor sum of these two currents, and hence IL is equal to root 3 times of IP. As the case of single phase system, there were three power, active power, reactive power, and apparent power. Active power is given by VL 3 times of Vp Ip cos theta, as we have discussed earlier. As we know, in case of star connection, Vp is equal to VL by root 3, or Ip is equal to IL. Putting the value of Vp in terms of VL and IL, then it will be root 3 times of VL IL cos theta. Similarly, Q is equal to root 3 VL IL sin theta. Putting the value of Ip is equal to root 3 times of IL is equal to root 3 times of Ip. This equation can be justified. Similarly, the third power is apparent power, that is root 3 VL IL is equal to 3 times of Vp Ip. If the one phase power is known, just multiply with 3, then it will be root 3 times of VL IL, putting the value of Vp or Ip as the case of star or delta. Now, active power in electrical system can be named as real power, true power. This is this is has three names: real power, true power, and active power. Then again unit will remain same. It is in watt, it is in VAR, volt ampere reactive, and this is in volt ampere. Now power measurement in electrical system. As we know, electrical system may be of single phase system or three phase system. In case of single phase system and three phase system, the difference is of connection scheme. In case of single phase, we are having a phase and neutral. To measure the power in electrical system, there is a device known as wattmeter. Wattmeter is a special device which has two coils. One coil is connected in series with the load is known as current coil. The another coil is connected in parallel with the load is known as potential coil or voltage coil. This is the current coil. It has four terminals. The terminal which is connected directly with the supply is known as mains. Supply mains, where the terminal which is directly connected with load is known as load terminal. Though these 2 points are common to each other, this is known as common. Whereas if the point which is connected in parallel with the circuit to measure to develop a potential difference across this potential coil is known as volt. Now, M here means mains, L for loads, and C means commons, and V is the voltage. The current coil is connected in series with the circuit, where the potential coil is connected in parallel with the circuit. Wattmeter can be used for different level of voltage and current rating, because in this case of wattmeter, this wattmeter can be designed for different level of voltage and different level of currents, and hence always there is a multiplying factor for the wattmeter. When the whatever the power is measured by the wattmeter, it is always multiplied by multiplying factor into a wattmeter reading, where multiplying factor is always defined as multiplying factor is equal to V range of wattmeter, I range of wattmeter into my cos of theta of wattmeter divided by full scale deflection of wattmeter. Now, power measurement in single phase system. As we know, in case of single phase system, we are having only two wires. One it is known as phase, another it is known as neutral. The wattmeter is connected in the supply side. The M terminal is connected with phase, L terminal is connected with load, C terminal is common with M, whereas V terminal is connected with another neutral wire of the circuit, and hence it will complete the circuit of the wattmeter. Then power measured by this wattmeter is given by W, and which is equals to Vi cos theta. Or wattmeter, the power measured by the wattmeter is always a active power. And from here we can, if V and I are known to us by the measurement, then we can easily calculate what is the power factor of this load is. However, if this wattmeter is having some multiplying factor, that will be multiplied with this multiplying factor. Otherwise, if wattmeter having a unity multiplying factor, then it will be Vi cos theta. Now, power measurement in three-phase system. The power in three-phase system can be measured 1 wattmeter, 2 wattmeter, and 3 wattmeter. As far as this connection scheme is concerned, that depends upon whether your load is balanced load or unbalanced load. 1 wattmeter method is suitable for balanced load. 2 wattmeter method can measure balanced and unbalanced, whereas 3 wattmeter method can also measure balanced and unbalanced powers. Now, the 1 wattmeter method, if system is balanced, if we can measure power of one phase, then just multiply by 3, the total power can be measured. However, if wattmeter having some multiplying factor, then multiplying factor also considered. Now, how to connect wattmeter? If suppose we are having a star connected system, in star connected system there is a neutral. This neutral, if we are having only one wattmeter, it is connected in R phase and with respect to neutral. Since these two phases are having same power consumption, and hence the reading of this water is multiplied by 3, that will give the 3 phase power. However, in case of delta connection, if you want to connect a single wattmeter in a system, then this wattmeter is not connected over this line. This wattmeter has to be connected in particular phase only, then only it will going to measure the power of this phase. Now if we can measure power of one phase considering the load is balanced, then it will be 3 times of W1 again. Whether the connection is star or delta, the power measurement by single wattmeter in balanced system is always multiplied by 3, and hence it will be equals to 3 times of Vi cos theta, and V is the RMS value of voltage, I is the RMS value of current, whereas the cos theta is the power factor of the load.